Okay, look at this integral, and how do we start? Well, we may factorize the denominator. Now, how do we factorize this one? This x fourth plus 1 is equal to x squared plus 1 square minus 2x squared, right? Yeah, so this one is equal to x squared plus 1 square minus the square root 2x square. Okay, so this one is equal to x square plus root 2x plus 1 and x squared minus root 2x plus 1. So this denominator becomes, so therefore this one becomes x squared plus root 2x plus 1 multiplied by this one minus root 2x plus 1, right? Yeah, that's correct. So, and then we use partial fractions, right? So this one is a plus b, right, over x plus root 2x plus 1 plus cx plus d x root x plus 1. Okay. Then we integrate this one, we integrate these two. Well, of course, still there's some work to do to follow, but okay, this is one way we can do. But here I have a little better method, so let me start with this one. Okay, I let this one x is equal to t, reciprocal of t. Then this one is equal to 1 plus t2 minus 4, right? And it's negative t2, right? dt. Yeah. Okay, then change it to t. This becomes infinitive. It becomes 0, right? Now then we change the limits by cancelling that negative. So this one becomes 0 to infinitive. T inverse negative 2 to 1 minus t to the fourth dt. Then we multiply by a t to the power 4. So this becomes t squared, right? T fourth plus 1. Yeah. Okay. So if this is I, this is also I, right? So then 2I becomes, added these up, this is integral, this is equal to, I change the dummy variable to x. So this is, x to the fourth plus 1, right? And x squared plus 1 dx. Yeah, this is I, this is also I. And change the dummy variable to x, then you have this. Now, instead of doing I, I'm doing 2 i's. It's a little better than the method I mentioned before. Now, this one is equal to, well, we can factorize this one to this, right? Okay, so this one, therefore, is equal to So the integral from 0 to corresponding to this one, this will be x squared plus root 2x plus 1 multiplied by x squared minus root 2x plus 1. So dx. Now here, x squared plus 1, I change to this. X squared plus root 2x plus root 2x and plus 1. Now here I don't have a root 2x, right? Then I take away root 2x. So that is equal, huh? Yeah, okay. Then I have this over this, right? Minus this over that. Become two fractions. The first part, this over that, you cancel the first, it becomes 0 to infinity, and this becomes dx x squared minus 2 root x plus 1 minus root 2 integrals. Now this over that, I change back to x plus 4 plus 1, right? And x dx. Yeah. Okay, so far so good. And this one, now this is a rather obviously that we are using the complete square for tangent. Okay, now let me do that one. Okay, here this is 0 to infinity. Dx, well, x minus 1 over root 2x, 1 over root 2 square, that will be x squared minus root 2x plus 1 over 2. So you have a 1 here, so plus another half. Plus another half, yes. Minus root 2. This one is rather easy, the x squared, right? Plus 1. And I change x dx into half dx squared. Well, I hope everything follows. Now, this one, I won't use the formula arctangent, right? This is something square plus 1 d something is equal to arctangent something, right? So I won't use this one, this formula. To create this formula, I need I need to change this to 1, right? So I take half out, bracket. This is 1 over root 2 square, right? Square cancel half. So this one is x minus 1 over root 2. And plus 1 now, yeah. Okay. That one square is this. This square is a 1/2 times the 1/2 cancel out. This time this one is 1/2. Now this is the formula. So I need a d something. What is this? This is you flip root 2 on top, becomes root 2x plus 1, right? Minus 1, sorry. Minus 1. Minus 1. Huh? And no more equal, because I have a dx. To balance with this one, multiply 1 over root 2. Okay. So far, now is good. Minus root 2 multiplied by half. Right? This is arctangent x squared from 0 to. Okay. Continue. Now I can use the formula because this is the formula, right? So this is equal to, this is a root 2 over 2, so this becomes, flip over is a root 2, right? Root 2, no, let me write this way, is equal to root 2 arctangent, root 2 x minus 1. Yeah, 0 to infinity. Okay. Plus this one, right? This one is 1 over root 2 arctangent square 0 to infinity. Well, so far so good. So this one is a root 2. Now, infinitive is half pi. Arctangent minus arctangent negative 1. Arctangent negative 1 is negative quarter pi. So negative is a plus quarter pi. So this is for that one. And minus 1 over root 2. That will be half pi. And minus 0. Right? Yeah, so this one is equal to is equal to 4 3 root 2 right? Pi minus this one change it to times the root 2 is 4 root 2 pi. So this one is equal to no, I too many pi. This is root 2, sorry. Okay. Minus half. So this one is equal to half, right? Half. Yeah, half root 2 pi. Okay. Okay, this is 2i. So I is equal to root 2 over 4 pi. So this is my solution to this one. Okay. Well, that is integral for this one, definite integral. Now, then do the second one. Second one is dx over x plus x to the power of 6 from 0 to infinity. Now, same story. This could be factored, right? This could be equal to x 1 plus x square cube, right? So that could be using the formula of this one equal 1 plus x square, right? Multiplied by 1 minus x square plus x fourth, right? So 1 over x to the power 6 is equal to, this is by what? By partial fractions, yes. This one is irreducible, okay? Then this becomes 2, right? This becomes 2 factors. Then you have a numerator. This is x plus b, right? So this is, say, if this is quadratic, then this is cx plus d, ex plus f. Then you integrate this, integrate this one, integrate that one. Okay, this is very, very tedious and very complicated. But I have a better method, similar to the x to the 4th. First, I replace x by xt to the negative first. Okay, and then when x is 0, that's the infinity, right? When x equal to infinity, that's a 0. And this will be 1 plus t to the power negative 6 and negative t to the negative, right? dt, yeah. Okay. Then I multiply by t to the negative 4th power by changing negative to flip over this one, right? And you have a t to the 6 plus 1, and this is t to the 4th dt. Yeah. Okay, this is also I. This is I. I change it to, well, dummy variable to x, right? 1 plus x 6, x 4th, and dx. And then 2i is equal to 2i is equal to 1 plus x to the 4th, 1 plus x to the 6, right? From 0 to infinity. Then I factor this one into factorize into 1 plus, I said before, right? Let me find out. Yes, here. I can change this one to that, right? X plus x squared multiplied by 1 minus x squared plus x 4th. Okay. Now look at the numerator. I have x 4th. I don't have x squared, but I have 1. Therefore, x 4th plus no, not plus, so minus, sorry, minus x squared plus 1. Now, my numerator does not have a negative x squared, so I plus x squared again, so then equal, right? Something good, because of this part of the denominator, this part of the fraction, plus this one, no? I integrate different 2 integrals. So this one over this one is equal to 1 over, right? 1 plus x squared dx. This is this over this. It becomes this. And that over this one is 0 over infinity, right? This is equal to 1 plus x 6 dx. Yeah. Okay. This over this is this. This over this is this. Now this one is a tangent x, right? Yeah, from 0 to infinity. And this one This one is 1 plus x cube square, right? Yeah, that's 6. X square is dx cube multiplied by 1/3, right? That's equal, yeah. So this one is equal to this one is equal to half pi, right? Plus 1/3 arctangent x cube from 0 to infinity. So this one is half pi plus 1/3 half pi, right? So that would be 2 pi over 3, right? Yeah, 2 pi. Yeah. Okay, now this is 2i. Therefore, my I is equal to pi over 3. See? This method, makes this integral rather easier. Okay. Now, the reason I'm doing 4 and 6 because they are relatively easier. If you do dx x, if this n is 3, then you 1 plus 3, right? Plus this is 1 minus x plus x square, right? And you use partial fractions to integrate. Well, still okay because this 3 is not very high. If this number is a 5, then this is rather complicated because the denominator is 1 plus x plus 2 irreducible quadratic. They are very complicated. When you do partial fractions, it's not easy. So you need a separate lessons for that. And I think I did 4 and 6. That is relatively easier for this type of integral. Okay. I think I have another video, which is let me mention something here. Well, that is f of x over g of x when f and g are polynomials. Okay, so those integral we have done is just special cases. So let me prepare for this video now. If you are interested, you can find and see how to deal with the rational functions in general. Okay, thank you for your watching.